Yay, it's the last lesson before midterms. So this is the last material that will be on your midterms. It's another easy one, just like 7-3. Let's get started. All right, division property. Again, I want you to write down what it is in algebra instead of in words. When you are dividing, you are subtracting. Write it down, and I will show you a quick shortcut. All right, most of us remember PEMDAS, and hopefully specifically the way I write it, because multiplication and division, one does not come before another all the time. It matters what order your expression shows them. Okay, so here is my hint when it comes to exponents. Exponents kind of do the step below. So let's say I have a squared times a to the third. They are being multiplied together. So I'm going to go here to multiply. And with the exponents, I'm going to go a step down. Because the bases are being multiplied, I'm going to add the bases together. So I end up with a to the fifth. Let's say we have an exponent to an exponent. A squared to the third. There's an exponent to an exponent. So I'm going to go here to exponent, go one step down. I'm going to multiply them together. So that equals a to the sixth. Today we are learning with division. Let's say I have a to the sixth over a squared. So I'm going to go to my order of operations, division, and go down a step. I'm going to subtract. So this would be a to the fourth. All right. There's another way I like to think of this. Let's say I have a to the seventh over a to the second. I like to think in terms of competition. I'm a very competitive person. Here, the numerator a has a power of 7, and the denominator has a power of 2. So if they were playing tug of war, the top would win by 5. And we can put a 1 here if we want to, but realistically, anything divided by 1 is itself. Let's say the roles were reversed, and I had a squared on top and a to the 7th on the bottom. This competition, the denominator would win, because 7 beats 2 by 5. So the bottom wins by 5. That's my shortcut and the way I think of it, because I like competition so much. So let's try some of this tug of war thought process. We have 2 to the 7th over 2 squared. So when they play tug of war, the top would win by 5. Again, if the top wins, you don't have to write any of the denominator. It's just 2 to the 5th. Next we have b, x to the 4th over x to the 3rd, so the top wins by 1. C, we have a little more prep work to do. We have to distribute that squared first. So we end up with d to the 4th, e to the 3rd, over d squared, oh that's ugly, and e squared. So the top wins for d by 2, and for e by 1. So the answer is d squared e. Letter D is a lot more difficult. Here we go. We're going to go one number at a time. So let's start with the 3's. There's 1 3 on top, 2 on the bottom, so the bottom wins by 1. I can put the exponent to the first power, but I really don't need to. I can just leave the base 3. Let's look at the 4's. 4 to the 3rd on the top, 4 to the 4th on the bottom, so the bottom wins by 1. And the 5's, the top wins by 2. Realistically, I can simplify this very easily to 25 over 12. Okay, a good old scientific notation word problem. We have simplify 3 times 10 to the 10th divided by 6 times 10 to the 6th in scientific notation. When I write these, I like to keep the division sign like a fraction. All right. So 3 divided by 6, hopefully you don't need to use your calculator, is 0.5. And I'm going to subtract or see who wins. The top wins by 4. However, this is not proper scientific notation. Remember, the first number has to be between 1 and 5. So 0.5 is too small. And you move the decimal over 1 time. So that would be 5 times 10 to the third. Hopefully you would realize this is how many times you have to move to the right. If I wrote this out in standard notation, it would be 0.5 moves it over 4 times. 1, 2, 3, 4. 5,000. However, with this bottom one, I wanted to start with the decimal point behind the 5. So how many more spots did I have to move? 1, 2, 3. So the answer would be 5 times 10 to the third power. We have another word problem here. The Colorado Department of Education spent about 4.408 times 10 to the 9th dollars in fiscal year 2004-2005 on public schools. There were about 7.6 times 10 to the 5th students enrolled in public school. What was the average spending per student? Write your answer in standard form. So even though they want standard form, I'm going to start with scientific notation because 10 to the 9th and 10 to the 5th are pretty huge numbers. So I'm going to do what I did before. I'm going to write them as a fraction. And I already messed up. Sorry. All right. 408 times 10 to the 9th. And 7.6. Wow, it's an impressive 7. 10 to the 5th. Okay. So basically, I'm taking all of the money they spent and dividing it between how many students they had to find out the average amount of money per student. So I'm going to divide the front numbers first. That's 4.408 divided by 7.6. And I get 0.58. And I'm going to subtract the exponents. I have 9 and 5, so I'm going to get 4 here. That is scientific notation. Standard notation means move that decimal. So I'm going to move it 4 times. 1, 2, 3, 4. That leaves me with 2 zeros at the end. So it's 5, 8, and 2 zeros. Don't forget units. It is money per student. So that's how you do a word problem with scientific notation and division. All right. So please write down the next rule over by the algebra section. All right, so we are going to basically distribute the exponent again. Nothing super new. So for A, the squared goes to the 4 and the 7, so that leaves us with 4 squared is 16, 7 squared is 49. Here we have to the 4th power. So and again, the 4th power spreads to everything, 3 to the 4th. D, if we have squared to the 4th, that's an exponent to an exponent, which means we multiply. 3 to the 4th and f to the 4th. Does anyone know what 3 to the 4th is? 81. So it would be 81 e to the 8th over e to the 4th. Wow, look at this handwriting. All right. Try C on your own and pause the video, try it, and then play it again to see if you got it correct. All right, we have a parenthesis inside a parenthesis. So I like to divvy out all of the the inside parenthesis first, which means my numerator is going to stay the same. And my outer parenthesis is going to remain. Inside, remember, we're distributing the exponent. So I'm going to get x to the 3rd, y to the 3rd. I could distribute this squared right now, but a little shortcut is to get rid of these x's first. I have x to the 3rd on the top and x to the 3rd on the bottom. Because they tie, they have the same number. Neither of them wins, so I can actually just cross them out. They cancel. 2 squared is 4, And here we multiply them, so it'd be y to the 6th. All right, and last rule. Praise the Lord, we've learned a lot. This is combining the two rules we already knew. We know if you have a negative exponent, you're going to flip over the line, and in this case, you would flip the entire fraction, and then distribute the now positive exponent. Let's try these. I like to flip first, then distribute. So for A, I see that negative sign, so I'm going to flip my fraction. It's now 4 over 3 to the third power, and I'm going to distribute. 4 to the third is 64. 3 to the third is 27. Whew. All right, let's try B. I see that negative sign, so I'm going to flip it. Y to the third goes on top, and 2x squared goes on the bottom. And we're going to square the entire thing because the negative used its power to flip it. Now I'm going to distribute that squared. So I get y to the 6th over 2 squared is 4, x to the 4th. Hopefully you're with me. All right, here we go. 2 of them. If we see a negative, I'm going to flip it. 3 over 2. With the now positive exponent, same thing here, 2 over n, we're going to flip it, and then make a positive exponent. All right, 3 squared is 9, 2 squared is 4, 2 to the third, 2 times 2 times 2 is 8, n to the third, 6 to the third, I hope I'm right, is 216, m to the third. All right, unfortunately, we're not done, and we can do some cross-canceling here. Okay. So, 4 and 8, I can cancel those, and I'm left with a 2. 216 is divisible by 9, and I get a 24 down here. So I end up with 2n to the third over 24 m to the third. I'm still not done simplifying. I end up with n to the third, should be a 3, over 12 m to the third. The n and the m are not going to affect each other because they have different bases. We made it. So, best thing about these is to show all your work so you don't get overwhelmed. There's a lot of things to do in each type of problem, but persevere and I know you can get it.